Hello everyone. So in this video we will um, uh, talk about corollary um, and the remark. So we'll try to prove two things here. The first one is corollary, which is, I believe this is very important, which is the covariance between x and x. That will give me sigma square x. So in order to prove that, we need to write the covariance between x and x, and that equal to expectation of x minus expectation of x times expectation of x. Now the x times x, that is x squared, so that means expectation of x squared minus expectation of x times expectation of x is just expectation of x all squared. So that is the definition of the variance of x. So that is equal to sigma square x. So the covariance between x and x is just the variance of x, sigma square of x. Now we prove this corollary. So we need now we need to another remark, or we can say just another theorem, if you like to say that. So what we have in here, so in this remark we just have three random variables here, so x, y, and z, and we need to prove that the covariance between x plus y and z is just the covariance between x and z plus covariance between y and z. So to prove that, we need to write the covariance x plus y z, so that actually equal expectation of x plus y so that equal expectation of x plus y times z minus expectation of x plus y times expectation of z. So we have two terms here, x plus y and z. We need to multiply them together. So so that give me the expectation of, so x times z is xz, and then y times z is yz, so expectation of xz plus yz minus, we can enter the expectation to the second term here, so expectation of x plus expectation of y, so expectation of x plus expectation of y, and that all times expectation of z. Now we need to multiply expectation of x times expectation of z, and the expectation of y times expectation of z, so that give me expectation of x z plus expectation of yz minus expectation of x times expectation of z minus expectation of y times expectation of z. Now we have expectation of x z, and we have the expectation of x times expectation of z, and we have expectation of y z, and we have minus expectation of y times expectation of z. So we just need to rearrange them as follows. So we have expectation of xz minus expectation of x times expectation of z, and then plus expectation of yz minus expectation of y times expectation of z. So the first one here, first line, so that equal covariance x and z, and then the second one, that will be the covariance between y and z. Therefore the covariance between x plus y z is just equal to covariance of xz plus covariance of y and z. Y and z. So we prove that the covariance between x plus y and z is just equal to covariance between x and z plus covariance between y and z. I hope you enjoy the video. Thanks for watching.